Good morning, fellow skippers, and welcome to part 2 of my mini-series about the art of maintaining a logbook. So in part 1, if you haven't watched part 1 yet, I recommend that you do so before watching this part, because otherwise this part won't make too much sense. But what we did in part 1 was that I recommended a 2-mode way of making logbooks. In mode 1, you jot down data in lifetime while on board the boat. As soon as something interesting happens, and only when something interesting happens, you make a note in your notepad version of the logbook. And then a bit later, perhaps within 24 hours, when you're on a long voyage, you find a bit of time where you can sit down somewhere on the boat and type up. That's mode 2. You type up your notes and you annotate your notes with comments and more historical context. And the purpose of doing that is that you get a logbook which is much more suitable for documenting your thoughts and your decisions, and a more useful historical document after the journey. A better vehicle for learning as well. So those were the recommendations, and this video is about, well, how do I actually do it? What's the technical way of doing this? And also, what are the advantages of doing it in addition to the ones I mentioned in part 1? And here what I want to focus on is harvesting data from the logbook. So once you have your logbook in a machine-readable format, because you typed it up in mode 2, once it's in a machine-readable format, a whole world of opportunities with computation open up. And I'm just going to show you 2 examples in this video, but you can imagine many more. The first example has to do with generating Google Maps, or rather tracks that you can show in Google Earth. You can show them in Google Maps as well if you like, but tracks that you can show in Google Earth and study your track of your journey, share it with friends and so on. So that's the first example.
So let us look at one use of the data in the logbook. Remember, the logbook is now in machine-readable form, and therefore it's possible to extract all the recorded positions from the logbook. And remember, we had the dates in the logbook as well, so we can draw a map of the entire voyage and label the individual positions with the date where we were there, and other information like the wind or the speed we were doing at that observation, if that was provided in the logbook. So I've done that. Let me show you what that gives. And there it is. And it's really nice, you know, you can sort of move around and you can zoom in. So for example, if I want to show you where's that super nice anchorage on the west coast of Scotland that I write about in the logbook, well, it was there, very nicely protected, and we were there on the 27th of June. Or if I want to go to Barbuda, I can do that. Oops. Low Bay in Barbuda. Well, we found out that the world was closing down due to Corona, and therefore had to get ourselves out of there. This is a 10-kilometer long sand beach, absolutely amazing place. And you can zoom in, of course, and remember that amazing place. And this is precisely where we were at anchor. So this is this is just super nice to have. And of course you can use these maps in all sorts of ways. You can send this file. This is just a file you can send via mail to your friends if you want to share, or I'll put it up on toftsailing.com so that you can download it and look at it if you're interested. It's a small file, as I said, less than 100 kilobytes. And the point I'm making here is that all of this data is in the logbook, so it's really a matter of using the right technology to extract it. And then you get this nice feature. So that was that simple point.
The second example of harvesting logbook data is about creating tables that can help you understand the phenomena you experience while at sea.
So this table was generated by some software I have written, which extracted data from the machine-readable logbook. So the logbook contains observations of wind direction and wind speed, and of course over ground and speed over ground. And this covers the period from noon, May 13th, 2022 to Saturday around noon and a little bit after as well. And the point I want to make here is that creating a table like this can be a super good way to get an overview of what you actually experienced at sea, because this was quite an interesting 3 days. You see, among other things, I had some gale force winds here in the middle of it. And whereas the data in these 4 columns come directly from the logbook, and indeed the dates and times here, they come directly from the logbook. These last 2 columns were added by my program. They show the true wind angle. That is the true angle between the heading of the boat and the true wind direction. So if we take the first row as an example, using north as pointing up here, in the first line you see we are sailing at a course over ground 65 degrees. So that means that angle is 65 degrees. And the wind is coming from 217. So that angle from north down to there is 217. So what's the angle between the heading and the wind? Well, it's 217 minus 65, or 152, starboard tack. So that the logbook didn't say that originally when I first wrote down all the data, because I didn't calculate that. But because there was enough data in the original logbook to calculate these things, program can now do it. And that's kind of interesting, because now we get a first overview of what's actually happening. Whoops, in this sailing here, we are starting on starboard tack, and we are sailing with the wind on the quarter, starboard tack. And then at some point there is a jibe, and we continue on port tack again with the wind on the quarter. So let's now go through this a little bit more carefully to understand what actually happened here. So what I show you here is a map of part of the voyage. We're in the Atlantic Ocean. Here you have the Azores, and the blue line here is a track of Kaka's journey made after I returned. And I have plotted here 4 noon positions for May 13th, 14th, 15th, and 16th, respectively. So as we go through this, I will use arrows to indicate the wind direction. So this is a southwesterly wind coming from the southwest. And you'll notice as we go through it that the wind direction changes. I also use colors to indicate the wind speed. So light blue here means gentle breeze, 7 to 10 knots. light green is used for moderate breeze, and dark green for fresh breeze. Yellow means strong breeze, and red means gale. So in the logbook we have this table which summarizes data extracted from the logbook observations in the notepad version of the logbook. And we see that we start out with Kaka here on this position on the 30th of May at noon. And we're on starboard tack. We're doing 5.7 knots of speed. And the wind is out of the southwest. Everything is fine. We sail for 24 hours, and now it's noon position, May 14th. See, the wind speed has picked up a bit. And we are sailing in an easterly direction. The day after, 24 hours after, we're still sailing in a fresh breeze, mostly southerly winds, and we're plowing along 7.5 knots here. Then in the evening, at around, well, precisely at 23:05, something very interesting happens, namely a front passes. So at 23:03, I was still sleeping in my bunk, with the wind pilot steering happily at 20 knots of wind, which you can do no problem. And then within a split second almost, well, at least within a few minutes, the wind veered 20 degrees and was suddenly of gale force. So look at the wind arrow now. Wham! Sails are flapping, and I'm struggling to get on deck to save the boat, so to speak. And fortunately, it quite quickly goes down again to about 23 or to 23 knots, which is a strong breeze, but at least not gale force winds. And all of this happens within 10 minutes. So that's the passage of the front. Then a bit more time passes, less than an hour, and it's now gone down to a fresh breeze. I'm sailing due east, and I actually took a picture around this time of my instrument panel here at my chart table, where you can see here on the left the wind direction suddenly changes by 15 to 20 degrees, and at the same time the wind speed jumps from about 20 knots to 33.6 knots. So it was really quite something. And then it came down again, interestingly, to about 20 knots, but the wind kept veering throughout. This is a 1 hour time span you see here. So we are still on starboard tack though. Then around 2 a.m. in the morning, the wind veered even more. So now it's straight out of the west. And now there's no way I can sail starboard tack and come to the Azores. So I have to prepare for a jibe. So I started that jibe, and that turned out to be a bit of a nightmare. It took me an entire hour, but eventually I got the boat jibed. And meanwhile, the breeze had come down to a moderate breeze. And then at 9 o'clock, after another 6 hours, the wind died. So then I was hanging around for 3 hours till the wind picked up again a little bit, and then again from an even more veered direction. So now I could sail on port tack towards the Azores. So you see, if you followed the wind arrow here, you'd see that the wind, it was completely classical passage of a cold front, where the wind starts out in a southerly coming from the south. then it veers and veers and veers, and at some point you're forced to jibe, and then it veers even more, and then you continue on the other tag towards your goal. So this is the sort of thing that is quite interesting when you collect the data, put it into a table, visualize it, and that's why I think it's a good idea to post-process your data and analyze it to gain an understanding of what you actually experienced while you were at sea. To produce the logbook in typeset format, as you see on the right here, I use a program called LaTeX. LaTeX, here you see the picture of the manual. LaTeX is built on something called TeX, which was released by Professor Donald Knuth of Stanford University in the mid-80s. I think 1984 was the first release. And if you have never heard about this technology before, I can't recommend it highly enough to people who work in mathematics or computer science or many natural sciences. LaTeX is what Word is to people who work in business or in public administration. It is really a super good tool for producing text that looks nice. And LaTeX and TeX have some advantages that make them incredibly useful for the purposes of structuring logbooks and extracting logbook data. Something I wouldn't be quite sure how one would do it in Word actually, but it's doable if you know LaTeX and you know some programming as well. So LaTeX is used in a different way than say Microsoft Word. In Microsoft Word, you have what is called a "what you see is what you get" system. So you are editing what looks like the final document on the screen. The LaTeX is quite different in that you start by using a text editor to create a file. In this case, it's called root.tex, and it's a text file containing some commands or control sequences, as I'll show you an example of in a moment. And then you run this program LaTeX with this file as an input, and it produces another file as output, namely the typeset document in PDF. And you can then use Acrobat Reader or something else to view that document. So here is a piece of the logbook at the bottom in PDF. You see the header from Saturday 16th. And on top here you see the part of root.tex. So this is a file. Think of this as a file. And somewhere deep in that file there are these 4 lines. And the things that start with this backslash, they're called control sequences, and they are commands for typesetting. And all of these commands you see here are, or control sequences, are control sequences that I have defined in order to make my logbooks. So dayset is a control sequence which produces a horizontal line. That's what you see at the bottom there. That's the horizontal line before the date. Then there is a control sequence called date with capital D, and it has 4 arguments, Saturday 16 May 2020. And that's typeset down here by LaTeX. Then I have introduced a control sequence called TZ for time zone. And when I write time zone, I give it argument -2, it'll come out as time zone : UTC -2. And then I've defined this control sequence next, west to east crossing day, which produces all of this stuff from Marico Bay, San Martin towards Horta, Isla de Fayal, and it counts up the day count and says day, whatever it is, in this case 18 of the passage. So all of that comes from that. And then I have a control sequence for the crew, which in this case was just myself, so that comes out as that. So that's the way this works. You write these special control sequences, and they are then interpreted by LaTeX and converted into PDF. Here's another example. We see what comes out of it. It's an observation, the observation at 3 o'clock in the morning, where position is something long and complicated here. There's a boat velocity and a wind vector, apparent wind angle and barometer, and then some text, the comment here. How did I enter that? So I used a control sequence I've defined. It's called new ops, and it has one parameter, which is the time. So that produced the bullet and the time, and set it up so that the rest will be typeset as a paragraph that's indented 1 centimeter. Then this long thing is then the position. It becomes this typeset. And then course and speed over ground 50 and 5.2, that's then typeset as that. And so on. You see that all of this data is recognizable because it's parameters of control sequences that are specific for logbooks. And that's why other programs can also find these data and do interesting stuff with it, like producing maps or tables about frontal passages. So, for example, the program that produces the map we saw in Google Earth, it scans through the root.tex file. The program is called MakeTracks. It scans through the root.tex file, and then it picks out the relevant data. So we wanted to pick out the date and actually the time zone, and we wanted to put out select times of day where we made observations, and the longitude and latitude, and some wind data. So the program chews through this and then produces this output, which is a piece of the file GPX, and it's a sort of XML-based language for describing geographical positions. It requires some computation to create it, because you have to convert the longitude and latitude to decimal degrees, and you have to convert time to UTC, but otherwise it's just text here, and that's the text inside the name argument here that you will see if you hover the cursor over the point in the track on the screen. And of course, this MakeTracks program is super fast. It doesn't do very much work, so it takes a few seconds just to run through the entire logbook and produce the track. And similarly for the table, we saw in our second example, here is the piece of the PDF file which contains the observations for 3 o'clock in the morning on the 16th, and that is what delivered most of the data here. All of this data in these columns come from, not from the PDF file, of course, but from the root.tex. And then my program calculated the true wind angle as well. So here are the details. That's what it looked like in the root.tex file. This is exactly the same as you saw in the previous example, in example 1. But now we produce a different output, namely some text code with some fields separated by ampersand. That's how you do in text when you create tables. And it has then produced this data and done this calculation that it was port tag and it was 135 degrees. And that's how that table was created. And then what I did after that was that I then took that text code, which was produced by my own program, and inserted it into root.tex at a suitable place in the document, so that now the nice table is actually part of the logbook, It comes in a figure somewhere before the observation of that day. So in that way you can keep elaborating on your logbook and make it more and more interesting. To sum up, far from technology making logbooks superfluous, technology can help you make logbooks that you can use to strengthen your strategic understanding of the situation you're in, document long-term learning, and make a historic record of your journey on top of all the things you can do with a classical physical logbook. I hope to have convinced you that it's possible to combine the use of a physical logbook and a digital logbook to get the best of both worlds. If you want to see more examples of how I write logbooks, go to toftesailing.com, where you can download free excerpts of my logbook from Carcass Atlantic voyage in 2019 to 20. Over there you can also buy the entire logbook, either as an ebook or now also in paperback, if you want to learn about our voyage, which was quite an interesting one. If you're a LaTeX user and would like to use my control sequences to create logbooks that look like mine, you're welcome to do so. Pop over to toftesailing.com, where they are available for download, free of charge. You'll also find a reference to the user manual for LaTeX at toftesailing.com if you want to learn LaTeX. And I have links on this page.
Thank you for watching.